Okay, for this last topic of the worksheet, we're going to look at solving systems of equations where we have no solution or infinitely many solutions, and we're again going to focus on that addition method, okay? So a couple of reminders. Remember, a system of linear equations with at least one solution is called a consistent system, and a system of linear equations with no solution is called an inconsistent system, and for us, this occurs with parallel lines. Now, there's one other definition that I didn't include that I should have. We also have this idea of dependent equations. These are two equations that graph the same line. And that's the kind of equations we have when we have infinitely many solutions. We're looking, remember, for that point of intersection. So if two lines are parallel, they never intersect, which would indicate no solution. Or if we have two dependent equations, those equations graph the same line. They intersect at every single point. So that would be where we have infinitely many ordered pair solutions. So let's go ahead and look at example 2. It says solve each system of linear equations using addition. Remember, that could also be called the elimination method. Write the answer as an ordered pair. Okay, so let's get started. So for part A, we have x plus 2y equals 2. And then we have 2x plus 4y equals 4. Now, it does not matter if you want to get rid of the x's or the y's. Just remember, you're looking to make sure that the coefficients on whichever variable you choose to eliminate, the coefficients need to be opposites. Okay, so let's just say for the sake of time, we've decided we're going to get rid of x. Well, if we look at the coefficients of x, they're currently 1 and 2. So the smallest number 1 and 2 divided into evenly would be 2. So I want to make sure the coefficients on the x's are 2 and negative 2. So since the second equation already has the coefficient of positive 2, let's take that first equation and multiply it by negative 2. So when I multiply the first equation by negative 2, I get negative 2 times x. Negative 2 times 2y is negative 4y. And negative 2 times 2 is negative 4. And then I just want to drop down the second equation. I don't need to manipulate it at all. And it just stays 2x plus 4y equals 4. Well, hopefully at this point you're like, whoa, something's happening here. Yes, something is happening here. When I add the two equations, look at what happens. Well, negative 2x plus 2x is 0. Negative 4y plus 4y is 0. And negative 4 plus 4 is 0. So we end up with a situation where we get 0 equals 0. This is, of course, true. So this tells me there are infinitely many ordered pair solutions. That goes even further to tell me that these are dependent equations. So if I really got down to it and I were to graph these two equations, they would graph the exact same line, okay? So we're looking with a system of equations for the point of intersection. Well, if we have two equations that graph the same line, they intersect everywhere, okay? So what you want to do is you want to write your answer in set notation. So we do the curly braces. We want to state the type of solution we have. We need to make sure that we tell the reader, hey, the solutions are ordered pairs. So we start by writing just a generic XY ordered pair. You then put a vertical line. This tells the reader we're looking for ordered pairs such that, and then you just rewrite one of your equations. Now, a lot of times you'll rewrite one of the equations where it's in slope-intercept form, so you have like y equals. We're just going to kind of cut to the chase, and we're going to write x plus 2y equals 2. Now, this means, hold on, let me fix my end here. This means that we're looking for ordered pairs that satisfy x plus 2y equals 2. And since these two equations technically graph the exact same line, if ordered pairs satisfy x plus 2y equals 2, they automatically satisfy 2x plus 4y equals 4. So this is how we would write our answer when we have a system of equations that has infinitely many solutions. Okay, let's go ahead and jump over to part B. Now, one thing you have to remember, and we have to go way back up here on the worksheet. If we look at the steps to solve a system using addition, the very first step we had is, if necessary, write both equations in standard form. If we have them both in standard form, when we go to add the two equations, it makes addition really nice. So When we go back down here, let's go ahead and write these two equations in standard form first. So this first equation is not in standard form. To get it in standard form, I could just subtract 4y from both sides. So that would make the first equation 5x minus 4y equals -3. So all we've done is subtract the 4y from both sides of the equation. It cancels out, it just becomes a 0 on the right, and then it stays as a -4y on the left. The second equation is -15x plus 12y equals +3. Now, we can get rid of either x or y, does not matter which one. So let's say for fun this time we decide to get rid of y, okay? We could get rid of x or y, it doesn't matter. But let's focus on the y's. Now, the coefficients on y's are -4 and +12. What's nice about that is you already have the different signs. I need to plug my computer. You've already got the positive and negative situation, which is good. Okay, we just need to make sure the coefficients are the same number. So looking at 4 and 12, the smallest number 4 and 12 could both go into is 12. So I need the coefficients on y to be 12 and -12. Well, the second equation, the coefficient on y is already +12. So what we want to do is force the coefficient on y in the first equation to be -12. To do that, I would just multiply by 3. Okay, so the first equation is going to be 3 times 5x, which is 15x, 3 times -4y, which is -12y, 3 times -3 is -9, and then the second equation, I can just bring it down. I don't have to do anything to the second equation. So it's -15x plus 12y equals 3. We now add the two equations. So notice what happens with the x's and the y's. When I add 15x and -15x, I just get 0. -12x plus 12y is 0. And then -9 plus 3 is -6. So this simplifies to be 0 equals -6, which is not true. So this is false. This tells me there's no solution. And remember, no solution occurs when we have parallel lines. So if we were to solve these two equations for y, we could, we don't have to, but if we were to solve these two equations for y, what we would see is that they have the same slope, but they have different y-intercepts. So that means they have the exact same steepness or tilt. They're never going to intersect. So we would just state here there's no solution. Okay, so at this point, you've seen 3 ways to solve systems of linear equations. We can solve by graphing, which is really cool because it gives us a very good, strong visual understanding of what we're doing when we're solving a system of equations. We're looking for the point where those two lines intersect. The downside to graphing is it's not ideal to do by hand. You have to be like super precise and careful and make sure you really do get the point of intersection. So the graphing method is especially nice if you have like Desmos or a graphing calculator, okay? So I like to use the graphing method to check my work, okay? The two algebraic methods are substitution and elimination. Make sure you know how to do those by hand. It is tempting to just try to get through your homework really quick and just cheat and use Desmos, but you're selling yourself short and you're really harming yourself in the long run because you need to know how to do this by hand. When it comes time for quizzes and tests, instructors want to see the algebra, okay? So make sure you know how to do the algebra. Simply use Desmos to check your work, okay? So those are the 3 methods for solving systems of linear equations.